要为我们带来直播快讲的是尼采实业。尼采实业股份有限公司提供智能感测器及监控软体给校园、农场、工厂、冷链物流、旅馆及保全等使用者，同时在业界率先采用 ZigBee、LoRa、3.1D 及相关无线通讯协议技术，提供完整解决方案给电信预营商、建商及保全公司。那就让我们欢迎尼采实业的执行副总张世模先生为我们介绍他们的公司，谢谢。
Ladies and gentlemen, thank you very much for having me here in Digital Taipei 2016. And this is Johnson Chang from Niche Enterprise Taipei, Taiwan. Today I'd like to show you some of the test cases that we have done for the IoT solutions, including smart campus and like agriculture, smart buildings. So next please. Whenever we make any project, we want that the project can actually align with the business results. And this concept will go through the whole process throughout my presentation. Next, please. Next. I'd like to show you some of the structures that we have been doing for the IoT solutions. And in the very left, you have the end nodes. That's how we collect data and be controlled. And in the middle, there's a concentrator and gateway, as well as a network server. And the very right side, there's a page server. For example, this is like an app, iOS app, Android app, web app, kind of the application server. So this is kind of the whole process of the IoT structures. Next, please. And the very case I'd like to show you is really about logistics. Our slogan is really about from seed to shelf. So you can see from the agriculture side and to the distribution center and all the way down to the retail store. And all the way the temperature in communities has been measured and uploaded to the cloud. So whenever there's any out limits, you can get immediate notifications for food safety. So this can be applied in many industries. For example, like a campus, like the one that transport the food for the students and professors, as well as like they transport in this case, they transport the blood to the hospital. This kind of transportation can be measured and immediate notifications for the supervisors. So in this case, they just stop the driver and try to maintain the same temperature humidities for the blood. Next, please. And this is the real case. So we actually install the sensor inside the blood box package. And next, please. This is the blood package. Next. So every single sensor transmits the data through this in-car, the van, and then upload to the data center for real-time monitoring. Next, please. So you can see this is the application. So the reading is 7.4, 9.2, 7.9. Please remember, for every blood, you have to maintain under 6 Celsius, but all the measure has been go out limit. So this is really dangerous. This is why I want to do it in real time. Next, please. Next. Next. And in this case, I'd like to show you some of the aquaculture side. And aquaculture is part of the environment monitoring and automated control. So when it comes to the aquaculture, you can think about many sensors. For example, the soil, right? The soil sensors, or the wind sensors, or the dissolved oxygens for the water, and of course the temperature humidity sensors. So all the sensors can be read and to upload to the cloud for automation control. So this is what precision agriculture is all about. Next, please. In this particular case that we measured, this is a floor plan of a greenhouse. They install, in this case is 100 square meters. They install 75 sensors and they collect the data and make it as a heat map like this. So in this heat map, this blue line is meaning is a less warm, and this is pretty warm. So they want to put it in even. So think about that. We have a real case in Nanshan High School. and they want to measure the even of classroom or the whole class. So they want to benchmark each classes because some building is close to the west and some building is close to the east. So each class, they set the same temperature, but actually consume different power. So they want to actually doing the energy management kind of things. So this schema can actually imply and can actually applied by the agriculture, but also the smart campus solutions. And moreover, we can use this as a data center. Next, please. Next. Next. This is chicken farm. Next. Next. And this is particularly the automated control for the greenhouses. So the sensor sends the readings and report back to the lab, and the lab can send a command to the fence to control the whole greenhouses. Next. 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 Okay, and so let's talk about a little bit about the building automations that we have been doing. This is the particularly like a convenience store or the class or the building. So on the very end of the axis, the temperature is 26, but the inside is 18. So this is a very typical situation that we waste the power and energy, so that we can use the sensor installed all over and to make the environment more even, which means you spend $1 in HVAC, and then you can create optimization values for your customers. Next, please. And this is a real case that we install a sensor called occupancy sensor under a table, so that each table we can know whether there's a people or not. Think about it, if the whole area is empty, then we slow down the AC and turn off the light so that the sensor can be interconnected with the whole building and automation, so that you can have energy saving, energy management kind of a value for your customers as a building owner. Next. This is data center. Next. Next, please. This is the hotel automations that we install all the sensors and inside the hotel, so that all the measures can be reported by the control centers. And we give the guests an app so that they can check their preference for the lighting, for the alarm, for B&B, do not disturb, kind of things, everything you can control by an app. Next, please. This is a lighting control solution. In wireless arena, that we only know the sender and receiver, but actually there's lots of roles included in the structures. In this case, this is called the RF commissioner. Commissioner meaning you set out commands to all the lights. In this case, in the past we want to use the manual control, but now you can use simply a laptop and control the whole building scheduling lighting. For example, I wanted to like the 8 o'clock in the morning, I want to make it as a 60%, and to noon, I want it to the 20%. So you can schedule the lights with one single laptop. Next, please. This is also lighting control. Next, please. Okay. This would be my last example. That this is a typical California house. This is the house, because the water is really important and expensive, so that every single apartment at our house, they will have a rain collector, collect the rain into the water tank. And let me ask you a very simple question. Why water your garden if it is raining? If it is raining, the soil is wet, and you water your garden, then you waste your water and waste your money, and money is expensive, right? So in this case, we simply install a soil moisture sensors inside the garden, so that whenever you know the soil is wet or dry, if it is wet or it is dry in certain level, you just water by automation, so that you won't never spend extra money in water to your garden. Next, please. Next. 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 Next, please. Next. 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 Okay, let me show you. This example is about the plant factory. They want to do the PWM automation control, so they can control the light sources in an optimal way. Next. 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 Okay, so this is pretty much all of my presentations that we show you some of the real case that you can actually apply it in campus and agriculture, building automations, and residential. I hope you enjoyed this presentation. For more information, please visit our website www.nhr.com.tw. Thank you.
好，谢谢我们尼采实业。